number 6, we have a compound inequality. This is an AND situation, right? And for the purposes of solving it, it's not really necessary for you to recognize that it's an AND because it's already in the correct form. But this, just so you know, is equivalent. So this is the same as saying 3x plus 7 is greater than or equal to -2, and 3x plus 7 is less than or equal to 13. All right, those are equivalent expressions to the original. All right. So it depends on how you want to go about things in terms of solving. There's a couple of ways that you can handle it. One way would be to work with each inequality individually. Another way would be to work with the compound inequality as it is. All right. If you do it individually, there's pros and cons either way. If you do it individually with these, first you'd have to separate, and then later on you'd have to put it back together. All right. So for some people, that's a deal breaker. Right? If you work with it as it was, then you'd have to ask yourself, all right, how do I isolate the variable? All right? I want to get the x alone, so I'd ask myself, all right, how do I get it alone? I subtract off the 7. But if I subtract off the 7 from one piece of an inequality, compound inequality, I got to subtract it off from all parts. Right? That's one of the properties of equations and inequalities. Doesn't matter how many pieces there are. In order to keep it balanced, you'd have to subtract it from each piece or add it to each piece. All right. So we'd have -9 less than or equal to 3x less than or equal to 6. Then I would divide. I want to get the x alone, so I divide by 3. And I get -3 less than or equal to x less than or equal to 2. All right. And so from there, I could graph it. 1, 2, 3, skip a few, infinity. 1, 2, 3 in the negative direction, skip a few, negative infinity. Close circles on the -3 and the +2. Shade in between. Got a nice looking graph. If you needed an interval notation, which is often the case, you'd say, all right, where's my start? Where's my stop? My start's at -3. My stop is at +2. You'd ask what the fencing should be. The fencing should be square brackets because they're closed circles. All right. Open circles apply. Parentheses apply when you're dealing with open circles or infinities. All right. Not the case here, so we're good. We use the square brackets. Now, if you worked with it using the two distinct equations, or I keep saying equations, inequalities, you'd solve each one of them individually, subtract off the 7 in both cases. You'd get 3x greater than or equal to -9, 3x less than or equal to 6. Divide by the 3 in all cases. You would not have to do it both ways, obviously. One way or the other. But sometimes an and could be presented to you in this form. So we need to know how to piece it together to get the appropriate answer. So when you solve, you would get x is greater than or equal to -3, and x is less than or equal to 2. All right? So you'd have to think about what that actually meant. So graphically, that would mean to the right of the -3, to the left of the +2, where do they coincide? They coincide between -3 and 2, at which point you'd say, that's my solution set. All right? So that's where things get a little dicey with this. And I'll make this look a little nicer because I kind of did it a little haphazardly. This is my overlap. All right, but that's what we're looking for. The overlap in this case when we're talking about and, where they're coinciding with one another. All right, like I said, one way or the other, not necessarily both. As opposed to the or situation where you have to do them separately. All right, so that's the distinct difference. And when people struggle, that's where they struggle with just recognizing the difference between the two ideas. You're not merging. You see this compound inequality where it's that trio form, x in the middle, and then you have the two numbers on the outside. That only applies when you're dealing with an and situation. If you have an or, you're going to have two separate inequalities. In most cases, there are exceptions, but you're going to have two separate inequalities with an or symbol in between. All right, so subtract the 3, subtract the 5, 2x less than or equal to 4, 3x greater than 21. All right, divide by the 2. X is less than or equal to 2, or x is greater than 7. So on my number line, I need to account for a 7 here. Maybe I'll go by 2's. Yeah, so 0, 2, 4, 6, 8. Skip a few, infinity. And then 2, 4, 6. Skip a few, negative infinity. As long as you have a good measure of values, you're in good shape. All right. So I need to be less than or equal to the 2. That's shading to the left. I need to be greater than the 7. So that's going to be about right here, somewhere in between the 6 and the 8, and that's fine, we're just estimating. Shade to the right, and that would be our appropriate graph. So that's a good looking graph, for the most part. A little bit better now. If we needed an interval notation, we identify the start and the stop for each region. That's why I always put the infinities in. As lame as it might seem, I put the infinity in because that gives me a defined start. All right, so I'm starting at negative infinity. I'm going to the 2. Infinity always gets parentheses. The 2 gets a bracket, square bracket, because it's a closed circle. My next start is at 7. My next stop is at infinity, so 7 to infinity, parentheses on the infinity, that becomes a habit after a while. You're like, you don't even realize you're doing it. But parentheses on the 7, because again, we estimated this, but this is a 7 here. And the only thing that's new that you have to remember is that you unite the sets. You put the two sets together with a little u. All right, u without the tail, but I've never taken off any points if somebody's like, all right, I'll make a U, because he keeps saying U, so I made a U. What do you want, So just as long as it's a U, it's fine, but that's the appropriate U. It's supposed to be like a mathematical symbol. It's not actually really technically a U, it's just U-shaped, but something along those lines.
And do you only use the U symbol when it's an or statement?
Correct.
Thank you.
No problem. So when you're dealing with an or situation, you want to look at the two inequalities separately. You're never looking to piece them together at any point. In the case of the proportional one, the one on the left, where it's just a fraction, I would say equal if it were an equal sign, but greater than or equal 5, you can solve that in a pretty easy way. You just multiply both sides by 3. You're not multiplying or dividing by a negative, so you don't have to reverse the direction of the sign. That's an important thing to keep in mind. The only time, and it's come up pretty frequently, people are getting confused by that. The only time you're changing the direction of the sign is if you multiply or divide both sides of the inequality by a negative. what people are doing is they're just anytime they multiply or divide, they're changing the direction of the sign, and that's not a good thing. So we want to be careful about that. All right, so the 3's would cancel over here. You'd be left with an x plus 2. You have greater than or equal to 15. Or then for the second inequality, I have some like terms that I can combine. All right, if you have multiple instances of a variable, we want to combine them. All right, we want to get them together, because if ultimately I want to solve for that variable, I need them to be grouped together. So I would say, all right, well, what is 1x minus 1/2 x? 1 minus 1/2 is 1/2. So 1/2 x plus 3 less than 2. Then I carry on as normal. All right, so I'd subtract 2 from this equation or inequality. X is greater than or equal to 13. I'd subtract a 3 from this inequality. 1/2 x is less than -1, but then I want to get the 1/2 out of there. So I multiply both sides by 2. Still not multiplying by a negative number, so I'm not reversing the direction of the inequality. All right, so this is going to give me an x on the left. These would cancel. And this is going to give me a less than -2. All right, so I'm looking for a number or series of numbers that are greater than or equal to 13 or less than -2.
How do you get rid of the 1x? Like, when did you do that?
How did I get rid of sorry?
When did you get rid of the 1x?
This 1x?
Yeah.
Okay, so I combined that with the -1/2 x. I did 1 minus 1/2, and that became this 1/2. Good question. All right. Oh, I hit copy. I didn't want to hit copy. That was the last thing I wanted to do. Okay. So, in terms of a number line, it should be pretty easy. The or situations are, because I want to say there's less thinking involved, but that's kind of true. You do have to scale a little bit, because we got to get the 13 in there. So, maybe you go by 2s, 3s, 4s, whatever you think makes sense. I think 4s is fine. All right, so 4, 8, 12, 16. Skip a few, infinity. -4, -8, -12. You just want to go 3 in each direction minimum. I had to go 4 to the right in order to get enough room for the 13. So that's a little compromise there. But greater than or equal to 13, halfway between 12 and 16 is going to be 14. Halfway between the 14 and the 12 will be 13. So if you're ballparking, it's about a quarter of the way through, and that's perfectly fine. So estimation is okay. As long as you have a rough idea where it is, you're good. And then what I would say is just make a little note here that this is a 13. Now that's got to be greater than or equal, so fill in the circle and shade to the right. All right. The other one is x is less than a -2. So ballpark where that is, that's going to be halfway between 0 and -4. Make a little note. Shade to the left. All right, with an open circle because it's less than. Now for interval notation, I want to be thinking about the start and the stop, and I want to create a union. All right, so for each piece here, I have a start and a stop. So my start is -infinity. My stop is -2. For the other piece, my start is 13, my stop is infinity. All right. Infinities always get parentheses. Open circles always get parentheses. That's straight memorization at this point. And the 13, that's a closed circle, so that gets a square bracket. Then the only thing you have to remember, in addition to the other 10 things that you had to remember, is to put a U in between, because these two unite to create the final answer, the union between those two sets. I know it's a lot, but it's part of the process. All right, which is why we're spending so much time on this, because I mean, if you think about it, you know, it's number of pages in the packet. It's fairly short, but there's a lot of like little fine details that matter for a lot, and we don't want to gloss over it. All right. There was another problem I want to do, but I accidentally hit copy, so I want to see if I still have it here. Oh, I do. Okay. I'll scroll back to this so you can see it, but I just want to steal this example. So this comes right from IXL. It's a good problem because it comes up, you know, variations of this problem comes up fairly frequently. So you see that you have h's in multiple places along this compound inequality. All right. So the idea is that you always want to try to consolidate your variable. All right. So that means that you want to put all your variables together. Generally in the middle, if it's a trio form, if you have that triple form of a compound inequality, one piece, a middle piece, and then another piece, you want to put it all together so that the variable's in the middle. So the only way we could do that is to add from the outside in. So I look at that negative 15h on the outside on the left, and I say, okay, well, let me add that to each part and see what happens. So I'm going to add that here, but I'll also add it here to keep my inequality balanced, and I'll add it here. Now you see what happens, and these are all in, I believe they're in the challenge zone questions. They're all kind of the same theme in the sense that once you make that first move, all the variables on the outside, they all cancel out. All right, so gone and gone. Now they're in the middle. You have a 2, less than or equal. You have negative 2h plus 8, less than or equal to 16. Now it's just like a regular problem. All right. So then I would subtract the 8 from each part. I get negative 6 less than or equal to negative 2h less than or equal to 8. All right. Now, yeah. So then I would divide everything by negative 2 to get the h alone. Because I'm dividing by a negative, I'm going to reverse the direction of all the signs there. All right, so these inequalities, they're all pointing to the left, they're all going to point to the right now. All right, so because I'm dividing by a negative. So this becomes 3, we have an h, and we have a negative 4. And so this is one way to represent our final answer. 3 is greater than h, which is greater than or equal to h, which is in turn greater than or equal to negative 4. Or if you want, you could write this as negative 4 is less than or equal to h, which is less than or equal to 3. All right? I'm not reversing signs through any operation. I'm just doing it through the logic of it. All right? So if I say it's a matter of perspective, if I say that I am taller than you, all right, then you could turn around and say I am shorter than you. All right? You wouldn't then turn around and say, if I say I'm taller than you wouldn't turn around and say, no, I am taller than you. Right? Not necessarily. I mean, unless it's an argument, I guess, and you have reason to think so. But older. I mean, I'm definitely older than you, so we'll go with that one. I am older than you. You wouldn't say I am older than you. No, that's not true. One of them is true. All right, the other is false. All right, so 3 is bigger than h, which is bigger than negative 4. True statement. Which in turn means, if you flip it around, negative 4 is less than or equal to h, which is less than or equal to 3. All right, so you could write it either way, and both would be correct, but this one is less confusing because it comes as a consequence of the operations that we performed. All right. You just got to understand that sometimes, multiple choice questions, they could be designed to be tricky. I don't purposely make trick questions, but sometimes they are a little tricky, so just kind of keep that in mind. All right.